Hello students, in this lecture video, I am going to solve few problems on AC circuits. Okay, so first problem which we are going to solve is voltage and current for a circuit with two circuit elements connected in series is expressed by complete voltage equation. So what is voltage equation? Vm is 170 sine omega t. Omega is 6280 radians per second and pi is pi by 3, and the current flowing is given by Im sine 6280. This is your radians, that is frequency in radians per second, and this is your phase angle. First, you draw both the waveforms. Let us try to plot both the waveforms. So when you want to draw both the waveforms, you can write down in this form, or else we can just take this as pi. Okay, so exactly middle will be pi by 2, and then at 60 degrees it will be pi by 3. Okay, 60 plus 60 at 120 degrees it will be 2 pi by 3. Okay, then if you take this as a 2 pi, and then pi by 2 plus pi, so this will be 3 pi by 2, and so on. So what it means, V of t is nothing but 170 sine omega t plus pi by 3. So it is starting from plus pi by 3. Okay, so it will be pi plus pi by 3, that is 1 plus 1 by 3. So 4 pi by 3. So that means 4 pi by 3. Okay, so it will start from here and it is going to end at this point. Okay, in the same way it will start its negative half cycle and after 2 pi plus 60, 2 pi plus 60. Okay, so 2 pi plus pi by 3. This is your voltage waveform. Now what is the current waveform? Current waveform is starting at plus pi by 2. Current waveform is starting at plus pi by 2. So how we can draw is that it will start from plus pi by 2. So pi plus pi by 2. Okay, that means 3 pi by 2. It is going to end because the magnitude of current is small. I am drawing small waveform, and it will be something like this. And then it might have continued because it is starting at pi by 2. It might have started from this point positive. So this is your V of t, this is your I of t. Like that you can draw the waveforms. So he has not asked actually in the problem, but we can draw the phasor diagram of this one. That is, voltage is 170 plus pi by 3. That means at 60 degrees, your voltage will be there. That is, V is equal to 170 at an angle of 60. If at all you are drawing for RMS value, 170 by root 2 at an angle of 60 degrees. Whereas current is 8.5 root 2 at an angle of 90 degrees. So where we can draw the current phasor will be along with the 90 degrees line. So this is I is equal to 8.5 by root 2 at an angle of 90 degrees. So the what we can say, I leads V by 30 degrees. If okay, I leads V by 30 degrees. So determine the frequency. Very simple question. Omega is given, that is 6280. Determine the frequency. You know omega is 2 pi f. So f is equal to omega by 2 pi. That is 6280 divided by 2 pi. Okay, 6280 divided by 2 pi. So it is 999.4. Okay, so or approximately 999.49. Okay, so we can say it is approximately 1000 hertz. So that is about your frequency. Then determine power factor and its nature. So what is power factor? Cosine of angle between V and I. The nature indicates whether current lags the voltage or current leads the voltage. Clearly current is leading the voltage. So the power factor is leading type. So what is the power factor? cos of angle between V and I. So angle between V and I is nothing but, okay, 60 minus 90. Okay, so cos 30 degrees. So what is cos 30 value? 0.866, 0.866 lead. Why it is leading? Because current leads the voltage. Obviously, my circuit, he has not asked what are the circuit elements. We can even solve what are the, okay, what are the values of elements. So the circuit elements, because current is leading the voltage, the circuit elements is RC. Okay, it is a series of a resistance in series with a capacitance. I have to find out what is the R value, what is the XC value. Okay, power factor is leading, current leads the voltage. Now we will try to find out what are the values of circuit elements. In order to find out values of circuit elements, first I need to find out Z, because impedance of a RC series circuit is R minus AXC. So what is impedance of a circuit? V by I. You have to take in a complex value of V, complex value of I. So VRMS by IRMS. But what is 170? 170 is VM. What will be VRMS? VRMS is equal to 170 by root 2. Okay. In the same way, IRMS is equal to 8.5 by root 2. So VRMS is 170 by root 2 at an angle of positive angle 60 degrees, whereas IRMS is 8.5 by root 2 at an angle of 90 degrees. So root 2 get cancelled. That's why I have not used. So use your calci, keep it in complex mode. Okay. Enter the numerator 170 by 170 at an angle of root 60 divided by 8.5 at an angle of 90. Directly you will get answer in rectangle form. Keep your calci in complex mode. How to use complex mode, I have made a video. You can change your settings of your calci to complex mode, and then in numerator it is 170 shift at an angle of 60 degrees divided by 8.5 shift at an angle of 90 degrees. So what I will get is, I'm using my calculator, I got 17.32 minus J10. So directly I can say it is having a resistance of 17.32 ohms and reactance of 10 ohms. But he didn't ask about value of XC. He's asking about value of elements. So I know XC. Can't I find out? Okay, C value. See, XC is 1 by omega C. From that, C is equal to 1 by omega into XC. That is 1 by 10 into, what is omega? 6280. Okay. So 6280 into 10, take X inverse of that, you are going to get, so if you press E and G, 6280, take inverse of this, you are going to get, so 1.59 into 10 power minus 5 farads. Okay, 1.59 into 10 power minus 5 farads, or else we can say 15.9 microfarads. Both are correct. Clear? So I'll just repeat once again how we will solve the problem. First, we are drawing the plots. While drawing the plots, we have to ensure if it is phi is equal to 0, it will start from 0. If it is with an angle, with that angle, we are going to add. Okay. So it will start from pi by 3 plus pi, positive half cycle ends. Pi by 3 plus 2 pi, negative half cycle ends. In the same way, pi by 2 it is starting. Pi plus pi by 2 positive half cycle ends. pi by 2 plus 2 pi is negative half cycle ends. Then we can draw even phasor diagram also if he's asking. Then how to determine the frequency? By comparing this equation with standard equation, you'll get omega is equal to 6280. From that I can find out frequency. Frequency is 100 hertz. Then we can find out the power factor. Convert your, take your VRMS, use your IRMS, find out the angular difference between VRMS and IRMS using polar form of representation of VRMS in IRMS. Then cosine of angle between VRMS and IRMS, you will get power factor. And you can, if you draw the phasor diagram, or else current is having a more positive angle compared to V, current leads the voltage, so the power factor is leading. Then how to find out resistance and capacitance of the circuit? Find out Z. Keep convert your Z in a rectangle form. Then the real part is resistance, imaginary part is your capacitive reactance. So resistance directly you will get, capacitive reactance you can find out by using formula Xc is equal to 1 by omega c. Let us solve second problem, okay, wherein two circuits with impedances of 10 plus j15 and 6 minus j8 are connected in parallel to a supply current of 20 amperes. What is the power dissipated in each branch? So first branch is 10 plus j15, 10 plus j15. So it is a RL circuit. Second branch is 6 minus j8. So it is a RC circuit. So this is your Z1, this is your Z2. Okay, so minus j8 ohms. So simply it is a two parallel circuits and the total current is 20 amperes. How to solve this circuit? So you have to just analyze or go back to your network theory options. When the two currents are there, when there is a total current, it is passing through resistance R1, R2, then I1 is equal to, what is the formula? I into opposite resistance by total resistance, sum of the two resistance. In the same way, I2 is equal to I into R1 opposite resistance by R1 plus R2. The same thing will applicable here because we need to find out power dissipated in each and every branch. So we need to find out I1. So I1 is equal to total I into Z2 by Z1 plus Z2. So what is total current? He is saying 20 amperes into opposite impedance, that is 6 minus J8 divided by sum of Z1 plus Z2, that is 10 plus 6, 16 plus 15, this is plus 15, this is minus 8, 15 minus 8, okay, plus J7, okay, then you will get your I1. Use your calci, keep your calci in complex mode. Okay, first you can do the division part. 6 minus 8i, close the brackets, divided by 16 plus 7i. Okay, I will get a division part multiplied with 20. So generally you will get in a complex mode your current. Okay, so if you want to write down in a rectangle form, the current I1 will be 2.62 minus J 11.14. But better you can keep it in a polar form. Okay, when you represent this in polar form, it is nothing but 11.45 at an angle of minus 76.7 degrees. Similarly, I2 need to be determined. I2 is also I into opposite impedance, that one, by total impedance. So what is your I20? Opposite impedance is 10 plus J15. Z1 plus Z2 will be same. That is 16 plus J7. So use your calci, keep it in complex mode. 10 plus 15i divided by 16 plus 7i. So multiplied with 20. If you want to write in rectangle form, it will be 17.37 plus j 11.14. Or else we can convert this into polar form. So better to write in a polar form. So it will be 20.64 at an angle of 32.68 degrees. I got I1, I got I2. So what is the power dissipated in each branch? So when he is saying that generally the equations he'll say real power or reactive power, whenever he'll say power dissipated in each branch is generally it is a real power. Real power will be dissipated only in resistance. So the power dissipated in a branch 1 is equal to I1 square R1. So we have to take a magnitude. That's why I kept in a polar form. Okay. So that is 11.45 whole square into 10. Okay. In the same way, power dissipated in second branch is I2 square R2. That is 20.64 whole square into the resistance is 6. Okay, so 11.45 square multiplied with 10. So you are going to get 1311 watts. What about this? 20.64 square multiplied with 6. So you'll get 2556 watts. Okay. So if he has asked for what is the reactive power consumed, reactive power is consumed by the inductance, then we can use I1 square x1. If he asks reactive power generated in a capacitor, then we can say I2 square x. So this reactive will be, if at all he is asked total power consumed, then you can take in a complex mode, then it is P1 plus jQ1 is the power consumed. Okay, P1 is the real power, Q1 is the reactive power. What is the power consumed in the second branch is P2 minus jQ2. So this will be a negative value. Capacitor will, rather than taking the reactive power, it will give back the reactive power. So what will be the Q1 value? I1 square x1. Q2 value is I2 square into x. Okay. So you know x1, you know x2. So if he has asked that even reactive power also, we can use these formulas. So this is one of the problem where we are using the two impedances which are connected in parallel. So same problem you may ask by giving a voltage rather than the current. When your voltage is given, I1 is equal to V by Z1, I2 is equal to V by Z2. Then total current is equal to, don't take I1 plus I2 is equal to I. In AC circuits, I1 phasor, I phasor is equal to I1 phasor plus I2 phasor. You can see if you add 11.45, 20.64, both will not be equal to 20. So actually, if at all you draw the phasor diagram for this, so your I1 will be at an angle of minus 76.7, that is 11.45. Your I2 will be 20.64 at 32.6. This is your I2, 20.46. So it is like some phasor summation you may get around 20 at an angle of 0. Okay. Let us solve one more problem on a series circuit. In a series circuit containing pure resistance and pure inductance. So pure resistance means pure resistance only, and pure inductance is pure inductor only. Okay. The voltage is given by the expression I of t is equal to find sine 314t plus 2 pi by 3, and V of t is equal to 15 sine 314t plus 5 pi by 6. So for better understanding, I'll rewrite this equation as I of t is equal to 5 sine 314t Rather than in radians, what is 2 pi by 3 means 2 into 180 by 3. That is 120 degrees. Whereas V of t is equal to 15 sine 314t plus 5 pi by 6. 5 into 180 divided by 6. That is 150 degrees. 150 degrees. Okay. So this is the given data. So from the given data, what is Vm? Vm is 15 volts. What is Im? Im is 5 amperes. What is the frequency? 314 radians per second. So what is the frequency of 314 by 2 pi, which will be 50 hertz. Okay, what will be the VRMS? VRMS is 15 by root 2. IRMS is 5 by root 2. Okay, we can keep aside. So these problems, in these sort of problems for MCQs, they may ask what is RMS value, what is the frequency, what is the phase angle difference. So 15 by root 2. So it is 10.60 volts. 5 by root 2, it's 3.535 amperes. So sometimes he has not asked, but we have not done any problem with V average. So if it is a V average, it will be 2 Vm by pi or else 0.636 of Vm. I average, it will be 0.636 of Im. So what is the 0.636 of 636 of 15? So it will be average value is 9.54 volts. Average current is 0.636 into 5. That is 3.18 amperes. If he is asking in a problem, what is V peak to peak? V peak to peak is 15 of 15, 30 volts. What is I peak to peak? So 5 of 5, it will be 10 volts. Okay. These are the things which he may ask, and then he may ask what is the angular difference between V and I, that also we will see. So what is the impedance of the circuit? So first, in order to find out the impedance of the circuit, Z is equal to VRMS by IRMS in complex mode. Okay. So what is VRMS? 10.60 at an angle of 150 degrees. What is IRMS? 3.535 at an angle of 120 degrees. Find out the value. Okay, keep your calcine complex mode. Enter 10.60 at an angle of 150 divided by 3.535, shift at an angle of 120 degrees. So directly you are going to get in a rectangle form. Okay, that is 2.6 plus j 2.596. I am taking it as 2.6 plus 1.5 ohms. So it is simply RL circuit, or else you want in polar form. So you can shift complex, convert that into polar form. You are going to get it as 3 at an angle of 30 degrees. So what is my impedance? My impedance is 2.6 plus j 1.5 ohms in rectangle form, which is equal to 3 at an angle of 30 degrees. So we got to find impedance value. And what is the value of resistance? If you compare your impedance with standard equation R plus Jx, resistance is equal to 2.6 ohms. Few textbooks will follow lengthier procedure. They will take 3 of cos 30 is 2.6, 3 of sine 30 is 1.5. But when you compare this directly, we can say this is your R. R is equal to 2.6 ohms. What is the inductance? Directly he has given that hint. It is an inductive circuit. We got XL. XL is equal to 1.5 ohms. So what is L? XL is equal to 2 pi FL. So XL is equal to 2 pi FL. L is equal to XL by 2 pi F. That is 1.5 by 2 into pi into 50. Okay. So what will be the L value? 2 pi 50 divided by 1.5. Take an inverse of the answer. So 4.774 millihenry. This is your inductance value. So inductance in henries is 4.774 millihenries. Now, what is the average power drawn by the circuit? If at all you do remember, average power is equal to, average power is nothing but P average Vm Im by 2 cos theta. This is the average power formula. Okay, so what is your Vm value? 15 into 5 by 2 into cos of angle between V and I. Angle between V and I is 30 degrees because it is a 30 degrees lag. Okay, so that is 15 into 5 divided by 2, or else in simple VRMS into IRMS into cos theta, that also we can take into consideration. Okay, multiplied with cos 30. So what you are going to get is 32.47 watts. 32.47 watts. 15 into 5. Yeah, 32.47 adds. So what is power factor? Power factor is either I can use cos theta. Cos theta is equal to cosine of angle between V and I, that is cos 30 degrees. So cos 30 degrees is equal to 0.866 lakh. 0.866 lakh. So like this, we can complete our problem. So in this problem, he is not asking about reactive power. Still, you can calculate even reactive power. Reactive power will be VRMS into IRMS into sine theta, if at all you are interested. So that is 10.60 into 3.535 into sine 30 degrees. So what is the reactive power value is 10.60 into 3.535 into sine of 30. So 18.73 volt ampere reactive. Then you can even find out S. S is equal to root of P square plus Q square. The units is in volt amperes. Okay. Like this, we can solve a problem in expression rather than V or I. V of t is given and I of t is given. Let us do one more problem wherein instead of giving in terms of V of t, I of t, directly in this problem he has given it is a RLC series circuit. R is 20 ohms, L is 0.2 henries, C is 150 microfarads. This is applied across a sinusoidal voltage whose RMS value is 230 volts, 50 hertz supply. Okay, so first find out XL. Very simple question. XL. XL is equal to 2 pi FL. So 2 into pi into 50 into L, that is 0.2. Units is ohms. We can do it. Calculation later. XC is 1 by 2 pi FC. That is 1 by 2 pi into 50 into C value is 150 into 10 power minus 6. The units of XC is also ohms. So let us find out XL, that is 100 5 into 0.2. That is 62.83 ohms. What about XC? 100, 5 into 150 microfarads. So take an inverse of this, you will get 21.22 ohms. I got XL, I got XC. Then what is Z? So Z is equal to R plus JXL minus JXC. So it is nothing but 20 plus J 62.83 minus 21.22. Okay. So it is nothing but 20 plus J 62.83 tell it minus 21.22 41.61. This is a shortcut, or else you want actually Z value. Z magnitude is equal to root of R square plus XL minus XC whole square. Or else you can convert this into polar form. You will get the same magnitude. Okay, so that is 20 plus 41.61 shift I. Okay, convert that into polar form. So it is 46.16 at an angle of 64.32 degrees. Even if you want to cross check this with this, you can cross check. That is 20 square plus 62.83 minus 21.22 whole square. Shift root of your answer. You will get 46 point. If you do like this, you will get only magnitude. If you do like this, you will get even phase angle also. So what is Z? Z we got. What is Y? 1 by Z. Okay, 1 by 46.16 at an angle of 64.32. So 46.16 x inverse is nothing but 0.02, okay, 216 at an angle of minus 64.32 mho. This is your x. Otherwise, you can take a rectangle form and take a 1 by 20 minus 1 by 41.61. Both are same. So this is your y. And then what is your power factor? Power factor you can do in the two ways. Okay. So power factor is equal to R by Z, or else cosine of angle between V and I. So what is angle between V and I? We need to find out. So he is not asking for I, but we can first find out I value. I value is equal to V by Z. So V I can take it as a reference value 230 at an angle of 0, and then Z value is 16 at an angle of 64.32 degrees. Keep your calcium complex mode. You will get directly answer 230 divided by 41.16. Sorry, 46.16. So that is 4.98 at an angle of minus 64.32 degrees. Then power factor is equal to cos of, okay, 64.32. So cos of 64.32. It will be 0.4333 lakh. This is your power factor. Okay. What is active power and what is reactive power? So active power is equal to VI cos theta. Okay, VI cos theta. What is VRMS? 230. What is IRMS? 4.98. And cos of 64.32. So 230 into 4.98 into cos of 64.32. So it is coming around 496.35 watts. What is reactive power? VI sin theta. That is 230 into 4.98 into sine of 64.32. So 230 into 4.98 into sine of 64.32. So it is 1032.26 volt ampere reactive. He has not asked in problem, but sometimes he may ask even about S. S is equal to V into I. That is 230 into 46.16. So 230 multiplied with 46.16, that is 10616 volt amperes. Okay, 10616 volt amperes. Sorry, I think not 46.16. Here I have gone wrong. This current is how much? 4.98. So 230 into 4.98. 1145 volt amperes. Okay, like this we can ask. Sometimes he may ask you to draw the phasor diagram. You can draw the phasor diagram, take V as a reference. Okay, then the current is lagging behind V by the angle 64.32. 64.32. So these current is a combination of your currents through the inductor, capacitor, and if at all you want to represent this current or V in terms of current, then you have to take current as a reference, then VR, VL, VC. So generally we can draw, because we are taking V as a reference. Generally we know the voltage, then the current flowing through the circuit is 4.98 at an angle of 60 minus 64.32 degrees. Okay, so let us do the last problem. I think, yeah. Let us do one more problem. A coil of 0.8 power factor is connected in series with, okay, a 110 microfarad capacitor to a supply frequency of 50 Hz. The potential difference across the coil is found to be equal to the potential difference across the capacitor. Calculate resistance and inductance of a coil. Calculate net power factor.